In this video, we're going to talk about derivatives and specifically about product rule. Now, whenever I'm talking about product rule, I should have a function that looks like as the product of two functions. Let me call the first one f, the other one g. Now, whenever you're applying the product rule, you should follow the following. So the derivative of y, as I said before, we can call it dy over dx, because I'm deriving y in terms of x, because here f is a function in terms of x and g is in terms of x. So the derivative of f times g will be the derivative of the first times g times the second as it is, plus the derivative of the second multiplied by the first function. So it's f prime g plus g prime f. Let's look at an example. So if you're given that a function y is equal to 2x cubed multiplied by 3x plus 5. I notice here we have product between these two functions. Now, for sure we can proceed in a different way than product rule here. I will mention two ways to solve this question. So, if I have product of two functions here, the first one is f and the other one is g. So to find dy over dx, or we can call it y prime, I need to do f prime multiplied by g. So what is the derivative of 2x cubed? The 3 goes down, we multiply it with the 2, so it becomes 6, x exponent 3 minus 1, which is 2. So this is the f prime times g as it is, so 3x plus 5, plus, now g prime, the derivative of 3x plus 5, so the 5 becomes 0, and the derivative of 3x is only 3. So this is g prime, and this was g, multiplied by f as it is, which is 2x cubed. Now, we can distribute. So 6 multiplied by 3 is 18, x squared times x is x cubed, plus 6x squared times 5 will be 30x squared, plus 3 times 2 will be 6x cubed. We can notice that this one and this one, these are similar terms, so we can add the coefficients. 18 plus 6, it will be 24x cubed, and the 30x squared will stay the same. If you want to solve this question in a different way, you can start with y and rewrite y as the sum of some terms. So I write it as a polynomial. So first step, we need to distribute. So 2 times 3 will be 6, x cubed times x will be x exponent 4, plus 2 times 5 is 10, x cubed. Now to find dy over dx, which is the derivative in this case, will be, the 4 goes down, so 6 times 4 will be 24, and we subtract from the 4 1, it becomes 24x cubed, plus we bring the 3 down, multiply with the 10, so it becomes 30x squared. As you can notice that this answer and this answer are the same. So in some questions you can apply different ways to get the derivative. Let's check example 2. If you're given a function that is radical of x plus 5 multiplied by 1 over x. So again, here we have product. If I'm gonna multiply here, I will not get a polynomial. So we have radical x over x if you multiply this with this, plus 5 over x. So this is not a polynomial. So it's not like x exponent something. We're not getting terms with x exponent something. Even though we can keep working with this, changing it, and then go back to the polynomial form and then try to do derivative, but this will be a long way. Instead of that, I look at the first one. So I consider this to be f, I consider this to be g. Now I'm just gonna do something here on the side so we can use them always as rules, which is derivative of radical x. So if I'm deriving radical of x, let's say y is equal radical x, then I know that the derivative of radical x will be 1 over 2 radical x in one step. We can take it like this always, so this is the rule for it. I'm just gonna prove it to you. If you look at y radical x, it's the same thing as x exponent 1 over 2. So the radical, we can change it as exponent half always. Then if I do the derivative here, dy over dx, I need to bring the half down. X exponent half minus 1. So it becomes half x exponent negative half. We don't keep negative exponents, so we need to take it next to the denominator. So it becomes 1 over 2x exponent half. As I just said before, the exponent half has the same meaning as the radical. So this will become 1 over 2. The exponent half is only for the x, so it becomes radical x. So only we change this because the exponent half is for the x. You can take it as a rule to solve fast. That's totally fine. Now, unless they tell you to prove it. So y equals 1 over x, the other one. The derivative of this is negative 1 over x squared. Why is that? This is the proof. Y equals 1 over x. The x has exponent 1. So just I'm gonna bring it up to make it x exponent negative 1. And we know the derivative of this is to bring the negative 1 down, so it becomes minus 1, x exponent minus 1, and we need to subtract 1 from the exponent. So we get minus 1 x exponent negative 2. We don't need negative exponents, so we should take the x exponent negative 2 to the denominator. So minus 1 stays on top. I'm just taking the x with a negative exponent. So the minus 1 is still up, and then we bring x exponent negative 2 to the denominator, and we change the sign of the exponent. So that's why we can take this as a rule. So you can memorize this one, and you can memorize this one. Now, going back to what we were doing, f in this case is radical x plus 5, and g is just 1 over x. To find dy over dx in this case, I need to apply the rule, which is f prime g plus g prime f. Now, what is the derivative of f? I need to do derivative of radical x alone, and if I know the rule, I can use it. So 1 over 2 radical x multiplied by g as it is, which is 1 over x, plus g prime, derivative of 1 over x. If I know the rule, I will write it minus 1 over x squared times f as it is, which is radical x plus 5, equals, the first one, we do 1 times 1 is 1, and in the denominator, 2 radical x times x, we can write it as 2x radical x in this way. For sure, we cannot multiply the x's because one is inside the radical, the other one is outside. Now, plus minus, we can write it as minus, but I will write plus here, and I will distribute the minus 1 for this one. You can do it that way. So you can write here minus radical x minus 5 in the numerator over x squared. So this is an accepted answer, unless they tell you need to rationalize the denominator. You remove the radical from the denominator. Alright. I will write the following. I will continue simplifying. So let's remove the radical from the denominator, because usually in math we don't keep the radical down. So to remove it, you just multiply it by itself. So whenever you have radical of something and you want to remove that from the denominator, you just multiply it by itself. So what I will get here, radical x here on top over 2x Now radical x times radical x, this will give me radical x squared. The square with the radical can cancel, so radical x times radical x, directly you can write it as x, plus the other one is x squared minus radical x minus 5 on top. Now as you can notice, x times x will give us x squared. So I'm gonna use this fact to make common denominator later on. So this is 2x squared plus minus radical x minus 5 over x squared. Now to add two fractions, I should have the common denominator. So here we notice we have 2, but here I don't. So I should multiply down by 2 and the whole thing on top by 2. Now let's continue working with this. The first one, it stays the same. I didn't change anything. And then the other one will become negative 2 radical x minus 10. I distribute the 2 over 2x squared. Now since we have the same denominator, I can write them both as one fraction. So we write radical x for the first, plus minus 2 radical x, it means minus 2 radical x, plus minus 10, it means minus 10. Now we can notice here we have radical x minus 2 radical x. We can simplify these because both of them, they have radical x. As if you are saying 1 apple minus 2 apples. The answer will be minus 1 apple. So instead of apples here, we have radical x. The minus 10 stays minus 10 over 2x squared. So this is the simplest form we might get for this question.